Hey everyone, today we're going to be graphing quadratic equations. So the graph of a quadratic equation is called a parabola, and that's that shape here. As you can see in our examples, it's that up and down shape or that down and up shape. And all of these are going to be in our standard form, ax squared plus bx plus c, but instead of being equal to 0, it's going to be equal to y. We're going to be able to start graphing that using those graphing calculators as well. There's a bunch of things that we need to be paying attention to here. First of all, how do you know if it's going to go up or down? And that has to do with your A value. Your A value sets the tone for that. Here, we have the arrows going down. That means that this is a negative A value. That's a negative A value there. Oh, I wish that erased a little better. Oh well. And on this side, the A value is positive, so we know it's going to go up. It's going to go up into the air. Some key terms here. The vertex is our most important point. It's where the axis of symmetry is. It's here, it's the maximum, and here it's the minimum part of the graph, depending on which way it's facing. So there, it's not going to go below the vertex there, and on this side, it's not going to go above the vertex. Our y-intercept here is where it crosses the y-axis, here, right there. X-intercepts, these are our roots. Let's see here, x-intercept, that's our roots, or our zeros, and what you're familiar with, zeros, are solutions. We've been working with factoring and solving quadratic equations by the quadratic formula, square roots, all those things. When you're graphing it, those are those solution points, is when they cross the x-intercept on your graph. All right, so how do you graph all this stuff? You're going to have to plot 5 points whenever you want to graph a quadratic equation. And there's simpler ways to do this and harder ways to do it, but we're going to work on strategies for making it the most efficient. We got to do the vertex, the x-intercepts, the y-intercepts, and at least one other point. There should be 2 x-intercepts here. Sometimes there'll be 1, sometimes there'll be 0. So this says one other point, but it also could be more than one. So let's figure out how we're going to do that. When we're finding the vertex, the x value is going to be negative b over 2a. Negative b over 2a, that's our x value. So let's take a quadratic equation like x squared plus 4x plus 4. We have our a value as 1, our b value is 4, and our c value as 4. So my x value here is going to be negative, taking this from right here. Negative b is going to be negative 4 over 2 times my a value is 1, which equals negative 4 divided by 2, which equals negative 2. For my y value, I'm going to plug x into the equation and simplify. Bringing that equation down here for my y value, I'm going to plug in x with negative 2 squared plus 4 times negative 2 plus 4. Negative 2 squared, I'm going to simplify that as 4 minus 8 plus 4, 4 minus 8 plus 4, oh that's nice, it equals 0. So my vertex for x squared plus 4x plus 4 is negative 2, comma, 0, x value, y value. There we've got our vertex. Finding the roots, we've got to solve the equation. Solutions are the x-intercepts. That's what you've been working on in class for so very long. Let's see here, nice green. Let's do the equation x squared plus 5x plus 6. I know that I want to pick that one because I can factor it. You can solve it however you want. 6 at the top, 5 there. I've got 2 times 3 equals 6, and 2 plus 3 equals 5. go to my shortcut, x plus 2 times x plus 3 equals 0, x plus 2 equals 0, x plus 3 equals 0, and so my solutions here would be -3, -2. And my y value is always 0, so when I'm looking for the roots, I know that the parabola is going to hit the x-intercept at -3, 0 and -2, 0. Those are going to be 2 points on the graph that I can find and plot. Finding the roots, that's my x-intercepts. And there, a lot of times there's more than one. Sometimes there's 1, sometimes there's 0. We'll get into that. But you just got to solve like you have been doing. Alright, what about the y-intercept? Not as two-sided there. The x value is always going to be 0. So let's just take the same equation we just had, y equals x squared plus 5x plus 6. And we're going to plug in 0 for x. 0 squared plus 5 times 0 plus 6. 0 squared is 0. Plus 0 times 5 is 0. Plus 6. So my y-intercept is going to be 6. So my y-intercept will be 0, 6. We'll be able to plot that on the graph. Finding other points on the graph. At that point, you're going to have to just look and see what you've been doing so far. Use something that's going to be advantageous for you. Y equals x squared plus 5x plus 6. We've been on a roll with this one. I'm just going to pick the number 1. It doesn't have to be anything. It can be whatever, as long as it's not 0. We need to be another point on the graph. I think that 1 will work out just fine as far as simplifying it, not too complicated. 1 squared is 1. 5 times 1 is 5. 1 plus 5 plus 6 equals 12. So I have plotted another point on my quadratic equation graph, 1, 12. All right, so that's how you do all those things. Make sure you get those down in your notes. Let's work on an example. All right, first of all, we always want to start by thinking about, okay, is this going to be, what kind of parabola is this going to be? This one's going to be pointed down. So I'm going to make sure that I recognize that right away. And then let's find our vertex. I think that's always the best place to start. So we're going to do -b over 2a. My b value is 2, and it's going to be -2 over, and then 2 times -1. -2 divided by -2 is 1. Okay, so my x value is 1. Now I'm going to plug that back into the equation to solve for y. -1 squared plus 2 times 1 plus 3. So you'll have to be careful here when simplifying, because the 1 is being inputted here for x, and that 1 is being squared before it's being multiplied by this negative symbol. So this is actually going to be -1 plus 2 plus 3. -1 plus 2 plus 3 is 4. So my first point, my vertex, is my x value is 1 and my y value as 4. 1 and 4. Alright, let's see if we can factor that. -1 times 3 is -3. We got 2 on the bottom here. If we are multiplying to -3 and adding to +2, we need a +3 and a -1. 3 minus 1 is 2. 3 times -1 is -3. If I go through here, let's go -x squared minus 1x plus 3x plus 3. Factor those. -x can come out of here, and 3 can come out of here. -x, x plus 1, plus 3, x plus 1. I'm going to set -x plus 3 equal to 0. -x equals -3, which means x equals 3. Here x plus 1 equals to 0, so x equals -1. So those are our x-intercepts. We also notice here a nice thing is that if you look at our point of symmetry, which is where the vertex is at the number 1, the -1 is 2 spaces to the left, the 3 is 2 spaces to the right. So I think we're doing something correct so far. All right, let's look at our y-intercept. How about y-intercept is when x is equal to 0. So y equals -0 squared plus 2 times 0 plus 3. 0 squared is 0, -0 is 0, plus 2 times 0 is 0. So we got 0 plus 3. I think our y-intercept is going to be at the point 0, comma 3. All right. So we know that we have to plot 5 points in order to solve for a quadratic. So let's be a little smart here. We know that from 1 to 0 on our x-axis, the blue dot to the green dot goes down 1. I think that the point we want to try and solve for is x equals 2. I think that's going to give us a nice point here, negative, and then we got 2 squared plus 2 times 2 plus 3. Remember our order of operations. 2 squared is 4. -4 plus 4 plus 3. And we've got -4 plus 4 is 0 plus 3. So the next point, when x equals 2, y also equals 3. Lining up there. From there, you do your best to graph it. There's no black color on here. That's really funny. Color have I not used? Well, I guess we'll choose this. So that should be enough to get our parabola going. We've plotted 5 points. You're not going to be graded on your artistic ability, but do your best. Show the 5 points and draw the graph there. All right, good stuff. Let's go to a new example.